Everybody. Good morning. I'm going to introduce me. I am Sebastian Buccelli. I'm 25 years old. My formal education is geographer and environmental engineer. The subjects where I'm more interested of my formal education is land planning, remote sensing, and topography. And my non-formal education includes interest in data science, including geodata science, machine learning, artificial intelligence, and technology in general, like Internet of Things and more. Well, continue with the present of my work and the pedestrian simulation methodology of evacuation in the area of Cotopaxi's lahar influence with SUMO. An introduction about the Cotopaxi volcano. It is part of the Andes mountain range in Ecuador. Its height is 5,897 meters and it's located in the Cotopaxi province in Ecuador. According to historical data, the most representative eruptive periods from 1534, it has emissions of CO2, pyroclastic emissions, long lahar flows, and volcanic explosivity index equal to 4. The population affected by an eruption of Cotopaxi volcano was determined by Ecuador Risk Management Secretariat, and they said that within an area of 913 square kilometers approximately, 93,000 inhabitants are exposed to the threat of lahars due to the eruption of volcano. Cotopaxi and Pichincha will be the most affected provinces. Justificating this problem, institutions specialized in defense and risk have coordinated simulacrums, but the behavior of people within an emergency will differ a lot from the behavior observed in a simulacrum. Then different open source software like SUMO and Python and other geoinformatics tools have been created to simulate different scenarios that allow to manage different variables and take the necessary aspects in order to show the emergency situations as real as possible. Well, the objective. Um, Here, a microscopic simulation methodology with a pedestrian approach will be developed into the current research to Los Valley within Rumiñahui Canton, where there are two possible scenarios. First, out of work and academic hours where there is only Rumiñahui's population, and second, in work hours where the population triples. Materials and methods. The area of influence is located, as I said, before in Los Chillos Valley, Rumiñahui Canton, in places that are affected by lahars produced by an eventual eruption of Cotopaxi volcano, considering the nearby sectors as safe places. Next step is collecting data, the road network evacuation route and population density from web platforms. The base of this pedestrian simulation is the road network file that is downloaded from OpenStreetMap and imported to .net.xml, that is a file extension read by SUMO. Then we add sidewalks, crossings, and walking areas issuing the following command to our pedestrian, to our road network, because it's a pedestrian simulation and we need person flows. The traffic analysis zones are source edges and sinks edges with this syntax and have a file extension .task.xml. These tasks are part of the OD matrix that have one source, one sink task, and the number of pedestrians that are in this traffic analysis zone. I generate the trip with OD2trip, that is an application included in the SUMO package. It needs the task file, the OD matrix, and a configuration file, as you can see here. and it's going to convert the audio matrix to individual scripts with this command. The generation of pedestrian demand was made with DUAROUTER, that is another application of the SUMO package. It calculates the shortest route using this algorithm. This is the configuration file that is in the following command. Well, finally, the simulation with SUMO-GUI, we have the pedestrian network and pedestrian demand that are the inputs. We enter the time period and the pedestrian model, in this case, the stripping model that allow interaction between pedestrians. We can execute it in SUMO-GUI, and we can see the traffic collapse and how is the behavior of the simulation. Well, it's all about SUMO, and the first, I made a macroscopic simulation where I mapped the results that give SUMO with the FCD file. I transformed it with Python into a pedestrian density file .csv, joined with the network file, and map it into a heat map. The discussion first, we have a neat pedestrian network with a background that is an orthophoto of Rumiñahui Canton that SUMO allows take these parameters. And the next is a simulation, two simulations of 20 minutes each one. We have here two hotspots, El Triángulo and San Luis Shopping, where approximately the 30% of people who began the evacuation at El Triángulo within working hours couldn't complete the evacuation. The people who could not complete the evacuation were those who began evacuation after 1 minute, 9 seconds, and the distance they had to travel was longer and was greater than 700 meters. Another of the hotspots, like I said, was the San Luis Shopping, and here the evacuation was not completed too. And to solve this problem, a vertical evacuation was simulated at the northeast area of the San Luis Shopping. I'm going to show it. Here are the heat maps where we can see the pedestrian density out of working hours here, and working hours. We can see how the pedestrian density increased. Comparing the heat maps, especially the two hotspots. In San Luis Shopping, we can see that people at the northeast of the mall, here is the mall, at the northeast are so far to the safe places. Then here was simulated a vertical evacuation. At the Triángulo, our working hours was complete the simulation, but in working hours, we can see that the traffic begins to collapse because the intersections that are in this part, and it's difficult to complete the evacuation. As conclusion, I draw that the evacuation simulation in SUMO, called it as microscopic simulation, together with a macroscopic simulation like that I said, are very useful tools to make decisions relative to different kinds of risk management. Taking into account that Ecuador has a large population that lives and works in vulnerable areas to different risks, like volcanic eruptions like this work, or tsunamis in the coast, landslides among others risks. Previous to emergency, we can say that evacuation simulation can be generated and it would optimize the resources. This simulation of evacuation was helpful to see how would complement a vertical evacuation for this emergency. And finally, we can see that Rumiñahui Canton needs to improve road planning and development. This will help pedestrians avoid bottlenecks, find shorter routes, and reach faster the safe zone. That's all. Thanks for your attention.